Hello students, welcome back to the math class. In our previous class, we have completed exercise 7.3 and we have discussed the properties of inequalities of triangle. In this class, we are going to discuss exercise 7.4. Okay, so let's begin. Students, question number 1 says, show that in a right angled triangle, the hypotenuse is the longest side. For that, we need to draw a diagram. So, let me draw a diagram so that we can discuss properly. Okay? Students, as you can see, this is a triangle ABC, right angled at A. Okay? So, triangle ABC is right angled at A. That means angle A is equal to 90 degree. That means angle A is the greatest angle of this triangle. Why? Because the angle sum property says that the sum of the angles of a triangle is equal to 180 degree. So, as angle A is 90 degree, sum of angle B and C is 90 degree. That's why angle A is greater than angle B and angle A is also greater than angle C. So, this implies BC is greater than AC and BC is greater than AB as well. Why? Because we have already discussed that the side that is opposite to the greatest angle of a triangle is the longest. So, BC is the opposite side of angle A. That's why BC is greater than AB and AC as well. Side opposite to greatest angle of a triangle is the longest. So, what is BC in this case? In this right angle triangle, BC is the hypotenuse. So, that is why we can write that hypotenuse of a right angled triangle is the longest side. See, we use a diagram of triangle ABC and we have come to the conclusion that hypotenuse of a right angle triangle is the longest side. That is why students, I keep on saying you, in these kind of questions, you need to draw a diagram so that you can understand the question in a better way and you can have a path to go through to reach the solution of that question. Okay. So, you also, whenever you are going to practice these kind of questions, you just draw a rough diagram and move towards the solution. Okay. Hope you have understood the solution of question number 1. Students, let us now discuss question number 2. It says, in figure, sides AB and AC of triangle ABC are extended to points P and Q respectively. Also, angle PBC is less than angle QCB, so that AC is greater than AB. The diagram is given in your book. So, to go for the solution, let me draw the diagram first, then we will proceed. Okay? Students, I have drawn the diagram on the board. Just concentrate and let us discuss the solution. Okay? What is given? Given that angle PBC is smaller than angle QCB. It is given that angle PBC, that means this angle PBC is smaller than angle QCB, these two angles. Okay. PBC is smaller than angle QCB. Fine. That implies 180 degree minus angle ABC. Why 180 degree minus angle ABC? Because angle ABC and angle PBC, they form a linear pair. That's why 180 degree minus angle ABC, these form a linear pair. So if I subtract this angle ABC from 180 degree, I will get angle PBC, isn't it? So 180 degree minus angle ABC is smaller than 180 degree minus angle ACB. Fine. What it implies? It implies minus angle ABC is smaller than minus angle ACB. So students, now we know that we have the smaller than sign over here. So to get the positive angles, when we interchange the position, we come to angle ABC is greater than angle ACB. Why? See, if I take this minus ABC over here, it becomes plus angle ABC, and minus angle ACB comes over here to give us angle ACB, and I have written in the proper order. Okay. So what it implies? ABC is greater than ACB. That means AC is greater than AB. Why? Side opposite to the greater angle is longer. Fine. So AC is greater than AB. Now we have proved that AC is greater than AB. Hope you have understood this solution. Just remember, you have to be very careful while implying the conversion of signs, otherwise you will be facing lot of problems. Okay, so you need to concentrate while changing the side, especially in this case. If you do not concentrate, it may happen that you will write ABC is smaller than angle ACB and you will come to a wrong solution. You cannot prove. You will prove that AB is greater than AC. If you do anything wrong while converting the signs over here, then you will come to a wrong solution. You cannot prove it. So you have to be fully concentrated. Okay, students, let us now discuss question number 3. It says, in figure, angle B is smaller than angle A and angle C is smaller than angle D, so that AD is smaller than BC. So let me draw the figure first, then we will go for the solution. Okay. So students, you can look at the diagram over here, or you can look at the diagram given in your book. The data given is angle B is smaller than angle A. It is given that angle B is smaller than angle A. Fine. That implies, which is the opposite side to angle B? It is OA. Which is the opposite side to angle A? That is OB. So OA is smaller than OB. Let me mark it as question 1. Fine. Why is it so? We know that greater angle has longer side opposite to it. Fine. Angle C is smaller than angle D. It implies OD, okay, is smaller than OC. OD is smaller than OC. Let me mark it as equation 2. So, from equation 1 and equation 2, what we get? OA plus OD, OA plus OD is smaller than OB plus OC. Okay, I have combined both the equation to come to another equation that OA plus OD is smaller than OB plus OC. What I did? I have just added. So, adding corresponding sides of equation 1 and 2. Equation 1 and 2. Adding corresponding sides of equation 1 and 2, I have come to another equation OA plus OD is smaller than OB plus OC. OA plus OD, OA plus OD gives me AD, that implies AD is smaller than OB plus OC, OB plus OC, that is our BC. So, we have come to the solution which has been asked by the question, that so that AD is smaller than BC. It is proved as per the procedure. Okay, hope you have understood this. Now let us discuss the next question. Students, let us discuss question number 4. It says AB and CD are respectively the smallest and longest sides of a quadrilateral ABCD. You can see the figure as it is given in your book. The question asks, so that angle A is greater than angle C and angle B is greater than angle D. So, let me draw the diagram first, then we will go for the solution. Okay? Students, I have drawn the diagram as it is given in your book. For solution purpose, we need to do a bit construction. Okay? What we have to do? We need to join B and D. Okay? Why I am joining? You can clearly understand ahead. So, we need to join B and D. Okay? So, let me join. Students, you can clearly see by joining B and D, we have left with two triangles ABD and BCD. So, we will utilize these triangles to come to the conclusion or solution part. Okay. So, let us first consider triangle ABD. In triangle ABD, in triangle ABD, AB is smaller than AD. Okay, AB is smaller than AD, it is given. As AB is smaller than AD, angle ADB is smaller than angle ABD. Why? AB is smaller than AD, that means angle ADB, which is opposite to side AB, should be smaller than angle ABD, which is opposite to side AD. Okay. Now, let me mark it as equation 1. Fine. Next, BC is smaller than CD. BC is smaller than CD. It is also given. Fine. So, angle BDC is smaller than angle DBC. Let me mark it as equation 2. Fine. So, adding corresponding sides of 1 and 2, what you get? Okay, angle ADB plus angle BDC is smaller than angle ABD plus angle DBC. Okay. So, what is ADB plus BDC? ADB plus BDC gives us angle ADC. is smaller than, what is ABD plus DBC? ABD plus DBC gives us angle ABC. Angle ABC. That implies angle D is smaller than angle P. Okay. Similarly, by joining A and C, we can show angle A is greater than angle C. Just concentrate and look how I have gone through the solution. While joining A and C, you will find another two pair of triangles and you can go through the way which I have gone through in this solution to find angle A is greater than angle C. Hope you have understood this solution. Students, let us now discuss question number 5. It says, in this figure or the given figure, PR is greater than PQ and PS bisects angle QPR. Prove that angle PSR is greater than angle PSQ. For the solution purpose, let me draw the diagram first, then we will go for the solution. Okay. So students, I have drawn the diagram as it is given in your book. In triangle PQR, PR is greater than PQ. Okay. In triangle PQR, PR is greater than PQ. It is given. Fine. So angle Q is greater than angle R. That implies angle Q is greater than angle R. Why? Angle Q is the opposite angle to the larger side. That's why angle Q is greater than angle R. Also, angle QPS is equal to angle RPS. First of all, let me mark it as 1. What else? Angle QPS is equal to angle RPS. This is 2. Why? Because PS is bisector of angle QPR. So, as PS bisects angle QPR, that is why angle QPS is equal to angle RPS. Okay. So, let me mark it as 2, which I have already marked it out. Now, by adding the corresponding sides of 1 and 2, what we get? It implies angle Q plus angle QPS. Okay, angle Q plus angle QPS is greater than angle R plus angle RPS. I have added the corresponding sides of 1 and 2. Okay. So, let me mark it as 3. Okay. Now, angle PSR is equal to angle Q plus angle QPS, isn't it? Angle, which one? Angle PSR, angle PSR. Angle PSR is equal to angle Q plus angle QPS. Can you say why? Hope you have understood this. See, PSR is the exterior angle, isn't it? This is the exterior angle of triangle PQS, and we know that the sum of the interior angles opposite to the exterior angle of a triangle, okay, is equal to the value of the exterior angle, isn't it? So, we know Let me mark it at 4. Why is it so? Exterior angle is the sum of opposite interior angles. So, for triangle PQS, PSR is the exterior angle and its opposite interior angles are PQS and SPQ. That is why angle PSR is equal to angle Q plus angle QPS. Okay. So, students, angle PSR is equal to angle Q plus angle QPS and angle PSQ is equal to angle R plus angle RPS. Isn't it? So, let me mark it as 5. So, when we combine 3, 4 and 5, what we will get? Exactly, angle PSR is greater than angle PSQ. So, by adding 3, 4 and 5, we will get angle PSR is greater than angle PSQ. Angle PSR is greater than angle PSQ from 3, 4 and 5. Hope you have understood this solution. Now, let us go to the next question. Okay, students, let us now discuss question number 6. It says, show that of all line segments drawn from a given point not on 8, a perpendicular line segment is the shortest. So, to go for the solution, we need to draw a diagram so that we can understand the concept clearly and go for the solution. So, let me draw the diagram first. Students, as per the given data, I have drawn a line L, okay, and AP is perpendicular to L. Fine. So, AQ is any other line segment. AQ is any other line segment. Angle APQ is greater than angle AQP. Angle APQ is greater than angle AQP. So, in this case, AP is perpendicular to L. AQ is a line segment. P and Q, they lie on line L. Fine. So, as AP is perpendicular to L, triangle APQ is a right angled triangle. That means angle APQ is greater than angle AQP because angle APQ is the greatest angle. Okay. So, it implies AQ is greater than AP. AQ is greater than AP. Why? AQ is the side opposite to the greater angle. That is why AQ is greater than AP. Hence, any line segment AQ from point A to the line L, any line segment from point A to line L is greater than the perpendicular, that is AP in this case. Okay, the perpendicular line segment AP from point A to the line L. From the point A to line L, which is AP in this case. We have proved that AQ, which is another line segment, okay, which is another line segment from point A to line L is greater than the perpendicular from that particular point A to that particular line L. Okay. Hence, AP is the shortest segment of all the sides. Hence, AP is the shortest segment of all the segments. Of all the segments. Okay. Hope you have understood this solution. Students, in this chapter, we have studied the following. First, two figures are congruent if they are of the same shape and of the same size. 2. Two circles of the same radii are congruent. 3. Two squares of the same sides are congruent. 4. If two triangles ABC and PQR are congruent under the correspondence A corresponding to P, B corresponding to Q and C corresponding to R, then symbolically it is expressed as triangle ABC congruent to triangle PQR. 5. If two sides and the included angle of one triangle are equal to two sides and the included angle of the other triangle, then the two triangles are congruent by SAS congruence rule. 6. If two angles and the included side of one triangle are equal to two angles and the included side of the other angle, then the two triangles are congruent by ASA congruence rule. 7. If two angles and one side of one triangle are equal to two angles and the corresponding side of the other triangle, then the two triangles are congruent by AAS congruence rule. 8. Angles opposite to equal sides of a triangle are equal. 9. Sides opposite to equal angles of a triangle are equal. 10. Each angle of an equilateral triangle is of 60 degree. 11. If three sides of one triangle are equal to three sides of the other triangle, then the two triangles are congruent by SSS congruence rule. 12. If in two right triangles hypotenuse and one side of a triangle are equal to the hypotenuse and one side of other triangle, then the two triangles are congruent by RHS congruence rule. 13. In a triangle, angle opposite to the longer side is larger or greater. 14. In a triangle, side opposite to the larger or greater angle is longer. 15. Sum of any two sides of a triangle is greater than the third side. So students, we have discussed the summary of chapter 7. With this, we have come to the end of chapter 7, that is your triangles. Okay? Revise everything, do not let go. You need to practice again and again, because mathematics can only be improved by practice. You need to practice more and more to grasp all the concepts and to make yourself stronger in mathematics. So keep revising, keep practicing, be safe, keep smiling. Okay? Thank you.